The Model Context Protocol promised to be the universal adapter layer for AI agent tooling, and in 2026, that promise is finally meeting production reality. Platforms like Composio and Zapier have shipped MCP integrations, and major LLM providers are embedding MCP support directly into their developer stacks. But there's a gap between the architectural vision and what actually runs in mission-critical pipelines. MCP is gaining traction as a standardized interface for LLM tool use, reducing the overhead of building one-off API connectors for every agentic AI workflow. The appeal is clear: a single protocol surface any compliant model or orchestration layer can consume without custom glue code. For teams scaling agentic AI toolchains, MCP looks like the missing infrastructure layer of the AI developer stack in 2026. At its core, MCP defines a structured handshake between an LLM and external tools, exposing callable functions, schemas, and context through a middleware server the model queries at inference time. Composio wraps third-party APIs behind MCP-compliant endpoints, while Zapier's MCP layer translates its existing automation graph into tool definitions an agent can invoke. Native integrations built directly into platforms like Claude skip the middleware entirely, passing tool context through the model's own API surface. The architectural difference matters. Each added layer introduces latency, serialization overhead, and a new failure point. Engineering teams running high-frequency agentic workflows report measurable latency overhead from MCP middleware, often noticeable per tool call under load. Context window utilization also degrades when verbose schema definitions consume tokens that could carry task-relevant data instead. For low-stakes automation, the convenience trade-off holds, but for latency-sensitive or context-heavy pipelines, native API integration still tends to outperform the abstraction layer. Builders evaluating MCP versus native API paths should benchmark middleware performance against direct connectors before committing to a toolchain architecture. The protocol is maturing fast, and spec updates are tightening schema efficiency, so the performance gap is narrowing, but it hasn't closed yet. Check the links below for the official MCP specification and Composio's integration documentation to run your own comparisons. If this breakdown saved you time, hit subscribe and like the video so more builders find it.